Hey, hi everyone. I hope you all are doing good. So, good morning, good afternoon, and good night to all the viewers across the globe. So, in my today's session, I'm going to cover the strategy design pattern belonging to the behavioral category of design patterns, basically. So, let's start with it. So, according to the Gang of Four, what strategy design pattern is basically it define a family of algorithms, encapsulate each one into classes and make them interchangeable. Okay, making them interchangeable means using a mechanism of aggregation basically. Okay, strategy lets the algorithm vary independently from the clients that use it. Okay, so what this particular pattern provides a solution is you define a family of algorithms or some solutions and you encapsulate into each classes and make them interchangeable at runtime. Remember this point, guys. Okay, as well as design time, both are possible. Strategy lets the algorithm vary independently from the client that use it. Okay, so you can basically have a n number of algorithms for one specific task. Okay, and you can change it at the runtime or the design time. Okay, so this pattern is used when there are multiple algorithms or solutions for a specific task and the client decides on the actual implementation to be used at runtime. In simple words, we can say that the strategy design pattern, also called as a policy pattern, attempts to solve the issue where you need to provide multiple solutions for the same problem so that one can be selected at runtime based on the runtime input parameters or the instructions provided by the client application. So that's all about the strategy design pattern, what it is. So what problems basically the strategy design pattern solves? Okay, the inability of algorithm to vary independently from clients that use it. Okay, so most of the time we encounter this problem where the algorithm is enable. Okay, it's not possible to vary it independently from the client code that is basically making use of that. Okay, the inability of differing the decision about which algorithm to use until runtime or tightly coupled solution in a client code. Okay, we don't have a mechanism to defer the decision of picking an algorithm at the runtime. Okay, or somehow we have tightly coupled the solution at the client code itself by exposing the algorithm specific data structures to our client application. Okay, non-flexible and reusable client code. Okay, so these are the three problems basically which strategy pattern tries to solve, guys. So what solution does this strategy pattern provides? As I already explained, let the algorithm vary independently from the client that use it. Okay, this one I'm going to demonstrate with the help of code so you people will understand very easily. And then differing the decision about which algorithm to use until runtime allows the calling code or your client code to be more flexible and reusable. Okay, so the UML diagram, very simple. We have a context. Basically, we have a context class, okay, which contains an operation, okay, and that operation basically triggers the strategies algorithm, okay. So as you would see, strategy pattern implements solution using the aggregation. Okay, it doesn't make use of inheritance, but it makes use of aggregation. So what happens is basically your context class contains a reference or a pointer variable to your strategy. Okay, you would say if you are using a abstract base class or an interface, then this context class will be simply containing a field called that interface variable, which is called your strategy interface variable. I'm going to show it in the code. Okay, and what it does is whenever an operation is called on the context based on your business scenario, that operation internally triggers the strategies algorithm. Okay, whatever strategy field you are maintaining on that, it will call the algorithm to perform that operation. Okay, so it is the context class which decides which strategy to pick. Okay, this is the public contract or public interface, okay, which specifies the operation or the task you would like to perform, and then you will provide the various algorithms. Okay, so take an example of transport. For example, okay, I want to commute somewhere, I want to travel somewhere, and I have n number of options. I can take the metro rail, I can take the bus transport, I can take the bike taxi, or I can take my own car itself. Okay, so what is happening is basically, okay, the standard operation or the strategy is to commute or to travel somewhere. Okay, so this particular interface over here, strategy, defines that operation. For example, travel. Okay, now how will you basically specify this travel strategy? Okay, there are n number of options, like as I already said, car, metro rail, bike taxi, and others. Okay, so what I will do, I will basically provide the concrete implementation for this interface. Okay, strategy 1, strategy 2, like that. Okay, so car transport, bike transport, metro rail transport, like that, I will provide n number of strategies. Okay, it's ultimately the context class, okay, to which we basically pass the strategy from our client application or the client code, which I'm going to show you soon. So just for high level information, in order to demonstrate this UML class diagram, I'm just explaining these stuffs. Okay, the client will pass the required strategy to your context object, and the context object will perform that operation, and that operation internally triggers the strategies algorithm which you want to basically perform that operation or the task. Okay, so let's move on. The advantages of strategy pattern. Okay, so I think this is one important point. So according to the strategy pattern, the behaviors of a class should not be inherited. Okay, as I already said, strategy pattern uses composition. Okay, strategy pattern uses composition instead of inheritance. Okay, so that's what the behaviors of a class could not be inherited. Instead, they should be encapsulated using interfaces. This is compatible with the open closure principle, okay, which proposes that classes should be open for the extension, but they should be closed for modification. Okay, so if you would have gone with the approach of inheritance, you would have given some pure virtual functions, okay, like travel or commute, and each subclass which inherits from your abstract base class would have given its own implementation for that, right? So what happens s- when there are scenarios where you have some fixed solutions, like metro rail transport? Just take an example. You want to travel, traveling is a strategy, and you have to pick a commute mechanism or a strategy basically. So you have only two options: either you can take metro rail or you can take bus, basically a bus transport. So in such cases, what happens, if you go with the inheritance approach, you will end up with overriding that code of metro rail transport and the bus transport into each and every subclasses you inherit from the base class. So basically, code is getting duplicated, guys. So just to avoid that, strategy pattern basically makes use of composition instead of inheritance. Okay. So that's the crux of the basic idea why it makes use of composition instead of inheritance. Okay. In the strategy pattern, behaviors are defined as separate interfaces and specific classes that implement these interfaces. Okay, so we basically specify a base interface for each kind of behavior. This is the behavior, basically the standard behavior. For that behavior, we provide concrete implementation, how to implement that behavior. Okay, so that's what they say in the strategy pattern. Behaviors are defined as separate interfaces and specific classes that implement these interfaces. This allows better decoupling between the behavior and the class that uses the behavior. Okay, this is your behavior and your client application over here. I have not drawn it. Okay, so basically all these context, all these things are used by your client application only, the end user application, you would say client code. So it basically decouples your client application from the behaviors code. Okay, so that's the main idea. Okay, this allows better decoupling between the behavior and the class that use the behavior. The behavior can be changed without breaking the class that use it. Okay, the behavior can be very easily changed in case of strategy design pattern. I'm going to show it soon. Okay, because you are making use of composition using a set strategy method, which I'm going to show you. You can very easily replace a strategy by other strategy at the runtime itself. Trust me, guys, no code changes required. That's the flexibility provided by this design pattern. Okay, the behavior can be changed without breaking the class that use it, and the classes can switch between behaviors by changing the specific implementation used without requiring any significant code changes. Behaviors can also be changed at runtime as well as at the design time. Okay, so there will be some scenarios where sometimes we start an operation with a default strategy, okay, which is called design time. You can set some default strategy in your context class, but over the period of time when the application start running based on the input parameters, the runtime conditions, the context class or the client application basically can decide which strategy to use and set that strategy at the runtime itself. Okay, no need of code changes basically. So now I will demonstrate one small program on this. So well, I will start with a strategy which is called iTransport. This is my base contract, guys. Okay. So this is the contract which basically specifies my strategy for which I'm going to provide concrete strategies which I'm going to show you. So what my interface contains, public interface iTransport, which contains one single method which is called travel. Very trivial example, okay, just for the demonstration purpose and for easy understanding, guys. Okay, so why travel string destination, to this destination I want to travel. Now let's move on. Let's see the concrete implementation for this base strategy or a abstract strategy, I would say. So start with the bus transport. See, the bus transport implements iTransport contract or the interface, and now it provides its own implementation. So, in case of suppose you want to travel to a destination, and based on your runtime conditions or based on the time remaining to reach that destination and the amount you need to incur in order to buy the tickets, the limitation on spending the money, for example, you can consider that you will pick which transport mode you want to select over here, or which transport strategy you would like to pick here. Okay, so this is the bus strategy, basically bus transport strategy. So very simple thing, travel, you will travel, reach to the destination point using bus with minimal cost and long journey. Okay, so this is the bus strategy. Then you go to the metro transport or metro rail strategy. Okay, same. Only thing is this method will be implemented, okay, based on the varying algorithm for your different needs. Okay, the basic agenda, the basic strategy is traveling. Basically, you want to travel from point A to point B, but how that traveling will be achieved, okay, that implementations will be provided into your various strategies, or you would say varying algorithms. So bus is one algorithm, metro rail is one algorithm, and then there's one more called bike taxi. Okay, this is one more algorithm. And then comes the context class, the transport context. Okay, so if you refer my UML diagram over here, context class always contains a reference variable to your base strategy. Okay, this is called composition. So if you come over here, you can see private iTransport selected transport. Okay, it contains a reference to your strategy. Okay, and while initialization of your transport context or context object, you can pass your strategy over here. That's what I'm doing. I will receive a strategy, okay, and I will set it to my uh, reference variable, the selected transport over here. Okay, and also at the runtime, based on different runtime conditions, if and else's, if I want to change some, if I want to change to different strategy, this set strategy method will allow me to set the required transport strategy over here. Okay, and then the important operation as per this UML diagram, which is called operation, which actually uses your strategy, is start traveling, and you will pass the destination, and based on the supplied transport strategy I will perform the travel operation. Okay, so this is the context object, very important stuff. Okay, using which you will basically set the various strategies at the runtime. You can set the initial strategy and then you can perform the actual operation. Okay, this is the entry point. And then the client code, very important. Okay, the client code picks a concrete strategy and passes it to the context. The client code should be aware of the differences between strategies in order to make the right choice. Okay, so the client code should be aware means your runtime application will decide what strategy to pass. Okay, if I want to reach a destination at less time and minimal ticket price, pick metro transport. If I'm traveling out to a highly congested area, you would say, or there is a more traffic, okay, in such case, and if you are going with a lot of friends, okay, in such scenario what I have done, see, I have went with the metro transport strategy. Okay, so this is one example I'm giving you over here, guys. Very trivial, basically. So I picked this, I passed it as an initial strategy to my context, and context will start that operation. Okay. Now, another scenario is, suppose I'm traveling to airport. So when you are traveling to airport, you usually plan everything in a planned manner. Okay, so you will usually leave 3 to 4 hours before itself, because airport is outskirts of your city usually, right? So in such situation, you pick a transport, okay, which can take time to reach that destination, and also it will basically provide you a less cost on your ticket prices. That's why I selected the bus transport over here, because cabs are very costly. So you can pick the bus, AC buses, just an example. Then suppose you are commuting to your office, okay, which is just 12 kilometer, but it has an immense traffic. So in such scenarios, what will you do? Two-wheeler is the best transport, right? So these are the runtime conditions. So your client application will decide what strategy to pick. Okay. So initially you may start with some default strategy. Okay. But over the period of time, when your application is running, your application may decide based on various input instructions or conditions which strategy to pick for the next operations or the next period of time, I would say. Okay, so simple example I have made use of. Okay, this is my client class, which basically creates an instance of my metro transport strategy, and then it will create the context class. It will set the strategy. Okay, it will pass to my transport context, and if you do ftol, you are setting the strategy over here. Okay, then you will perform the start traveling on the context object. Okay, so let me run this program and show you how things are going on. Okay, so my sorry, my yeah, breakpoint has been hit. So what is happening? First, I am creating a metro transport strategy. Let it create, and I'm receiving it in a iTransport. Provide a keen observation over here. Okay. Then what I'm doing, I'm setting my metro transport strategy to my transport context. So if I do F12, if you see over here, my selected transport is, which is coming as metro transport, right? And then I will start traveling. Okay. If you compare with the UML diagram, this is that operation start traveling, and it will basically call your strategy dot algorithm. So what is my strategy? My selected strategy is over here, which is metro transport, and then you will start the algorithm, which is travel. So if you do F11, you will go to metro transport and you will perform that operation. Okay, very simple, guys. So let's continue. So this is a sample run. So there were basically I started with the metro rail transport strategy, and then see over the period of time what all things I changed. Okay, so that's the sample output, guys. So how the program ran using various strategies. Basically, it used the metro rail, the second used the bus, third used a bike taxi. Okay, and interesting thing is, at the runtime, you can set various other strategies by using the set strategy method. Okay, so that's what I have made use of over here. When I set the strategy to bus transport strategy, I used the context dot set strategy method and I passed the bus transport, and then again I started traveling. Same I did when I want to travel to office. I set the strategy of bike taxi transport, and then I started traveling. Okay, so that's all about the demo. So yeah, one more point. Yeah. So when do we need to use this strategy design pattern? Okay. So when there are multiple solutions for a given task and the selection criteria of a solution are defined at the runtime, as I already explained, okay, then you should go for this strategy. When you want different variants of an algorithm, yeah, when you have multiple options to perform okay, when you have multiple solutions to perform an operation. Okay, when many related classes differ only in their behavior. Okay, when a class defines many behaviors and these appear as multiple condition statements in its operations. Instead of many conditional statements, more related conditional branches into their own strategy class. Usually, I have observed during the code reviews, okay, when there is the opportunity to implement strategy pattern, what people would have done is they would have implemented it into a multiple conditional statements. If it is equal to this, then do this. If it is equal to that, do that, else. So this kind of things, whenever you see this kind of things, right? So what you can do is you should identify if there is any opportunity to transform them into a strategy pattern, guys. Okay, so that is the one. And also, when an algorithm uses data that the client shouldn't know about, use the strategy design pattern to avoid exposing complex and algorithm specific data structures. Okay, so instead of this is very important thing. So instead of hard coding a solution into client application or client code and exposing all the algorithm specific data in your main program or your application program, what you can do is basically you pass that algorithm into a separate class, implement it as a strategy, and then you handle whatever data you are basically using in that strategy class itself. This way, you are not exposing the algorithm specific data structures to your client application. Okay, so these are the scenarios where you can basically make use of the strategy design pattern. I hope you people understood. Thank you for listening and have a nice day.